Hello, everyone, and welcome to today's session, Demystifying Git-based Salesforce Development Essential Git Insights. I'm Simon, and I'll be your host for today's session. So whilst we wait for a couple more people to join us, where is everybody tuning in from today? And also, if you're happy to share, what's your background with Salesforce? You're a Salesforce customer? Do you maybe work with Salesforce? But I'm tuning in from London today, and it is thankfully a little bit warmer than it has been for the past couple of days. But yeah, do let us know your answer to those questions in the comments. So whilst you pop those through, whether you're a complete beginner or looking to enhance your existing skills, today's session is designed to provide you with valuable insights and practical knowledge on Git-based Salesforce development. So throughout the next hour, we'll be covering what Git-based development is and why it's essential for your Salesforce projects, how to get started with Git, and also the basics of trunk-based development, which is a key practice in modern development workflows. This session is packed with essential tips and insights that will help you improve collaboration, ensure robust version control, and streamline your deployment processes. We are thrilled to have Harold from who is the CEO and founder of Hutte, and he will be here to guide you through all things Git. I'll be back later for the Q&A, but for now, I will leave you in his very capable hands. Enjoy the session, everyone.
Thank you very much, Saima, and good morning or good afternoon, everyone, wherever you are joining from. I'm excited to spend the next approximately 45 minutes with you to demystify Git-based Salesforce development, sometimes referred to as source-based development, and to equip you with the essential knowledge to kickstart your journey into working with Git for delivering work on the Salesforce platform. So what you can expect after a brief introduction, I'd like to help you understand what Git-based Salesforce development is, help you understand the key benefits of applying version control to your Salesforce metadata and power your Salesforce application lifecycle with Git. And we'll then do a Git 101, elaborating on key concepts, always obviously in the context of Salesforce development, both code and no-code development. So when I say development, that doesn't basically limit to Apex and Lightning Web Components, but really means every Salesforce configuration work, and then wrap up with a Q&A. So just a very brief introduction about myself. I'm based in Vienna, Austria. I've been working in software development for more than 25 years, leading different product teams on very different stacks, and have been working on the Salesforce platform since about 2017. I call that full stack because I've basically touched upon different aspects from data model to low-code development with flows to actual Apex development, Lightning Web Components, and so on. But my specific interest has been for long the application lifecycle management, and yeah, in my 5 years experience previously at a ISV company building basically a business application available on AppExchange, I had the chance to scale a development team and leverage basically Git to really be able to streamline and add efficiency to the whole development process of a team of developers as well as citizen developers, low coders, and so on, all basically contributing through Git version control on a, in that case, managed package for AppExchange. And then since 2022, I'm acting as the CEO and founder of Hutte. And again, this role is very closely linked to today's topic, which is very close to my heart. So basically, we help teams streamlining their Salesforce application lifecycle with tools for org development, org management, but also for supporting a Git-based development lifecycle with no-code tools. All right, so what is Git-based Salesforce development? What does it really mean? As many of you are certainly aware, nearly every configuration change in Salesforce is reflected in a change of metadata. So there are hundreds of types of metadata, which, from the various obvious things like page layouts, list views, to your standard objects like account, to custom objects, to Apex classes, triggers, flows, and so on. But also basically things you control from your setup, like org settings. Most of those are captured in metadata. So the metadata coverage, and Salesforce is basically frequently releasing updates. They have a coverage, metadata coverage report, but you can consider it basically close to 100% of an org's configuration being reflected in metadata. And metadata are typically XML files, or in the case of Apex, code, classes. And I mean, to just give you a very brief look at an enterprise edition's metadata. So this is the metadata browser coming with our own product, Hutte, but you could also use Visual Studio Code with the Salesforce extension to basically look under the hood what's in your org, and you will find here basically dozens of types of metadata, from the various obvious, like let's say objects, to classes, triggers, and so on. And basically working source-based means exposing this metadata, getting it from your development environment, and putting it under version control with a lot of benefits that I'm going to elaborate on in this demo. Let me just go back to my slides. Just basically two more basic terms or concepts that you hear frequently in this concept. So deploying is basically the practice of moving metadata between orgs. And then on the typical tooling, so to support Git-based development, to access these raw metadata files that are behind your Salesforce org's configuration, a very common setup is VS Code and a set of extensions that Salesforce is making freely available, including the command line interface, the SF CLI. However, there are also third-party tools and also Salesforce's own DevOps Center, which facilitate participating in a Git-based development lifecycle in a low no-code way, so abstracting away the complexity of command line tools and so on to interact with metadata. So I'd like to now compare the two essential ways of working with Salesforce: org-based and source-based or Git-based. So in a, let's say, traditional org-based way, you can make development work in any kind of Salesforce org. You can work directly in production, which is for many reasons obviously not recommended. One could argue if you are a single admin, it might be a legit practice, but even there, I would argue that there are a lot of benefits of keeping track of your changes in your org through or with the help of metadata and version control. So in a source-based application lifecycle, work is typically done in developer sandboxes or scratch orgs. These are the sandbox types that are dedicated to do development work. We know there are other sandbox types like partial or full copy sandboxes, which are essentially made for testing your work before deploying to production. the advantage or the reason why you should use developer sandboxes or scratchers is that they have the ability to internally track changes. So they have a hidden version control system under the hood, which then third-party tools can use to visualize and show you in a very easy way which metadata changes you have made. Because as you know, in working org-based, in an org-based model, it's basically your responsibility when you work with change sets to basically select the metadata that you have touched in your lower environment and then kind of define what you want to deploy to a higher environment. When working source-based, first of all, you can get some help by seeing changes that happened in your environment. And then you can also basically select this affected metadata and deploy it with command line tools or tools building on top of the APIs and command line tool that Salesforce provides. When we look at the effort, so working org-based is obviously quite tempting from a perspective of learning curve. It's quite easy to get started, to spin up a sandbox from your production org, start working, and then using change sets to move work from A to B. While working source-based comes with a bit of an overhead. So yeah, you need to basically understand some core concepts of Git, and my goal is to introduce you to them today during the call. But it obviously comes with a lot of advantages. So when we look at some obvious downsides of working org-based, so there is, and I'm sure many of you have experienced that, especially when working in larger teams and using the org-based model. So there is obviously a high risk of overriding work and in unintentional rollbacks. So imagine two developers working in two sandboxes of production, both touching upon the opportunity page layout in different work they are accomplishing. Well, whoever deploys their changes first will basically override the changes of someone else. So what some teams fall back to then is using shared environments, basically having multiple features developed in parallel by multiple people in a single sandbox, which of course, again, introduce a lot of intransparency and risk of getting into each other's way. And that is really where source-based or Git-based development shines. So there, the work of multiple team members can be integrated before being deployed in a very transparent way. By that, I would state that this way to work scales infinitely when we think of team sizes, whereas, as a team, you will very soon hit the limits of an org-based development. So this hardly scales to teams. And in org-based development, the orgs are kind of black boxes. So it's very hard to keep track. Environments are typically, unless, let's say, your sandbox is freshly refreshed from production, when you can assume it matches the configuration, the metadata of production, it's a very common phenomena that those drift away over time. And a major advantage of working source-based is that you have this documented state of each environment at any time. Summing up the key benefits of going Git-based. So very obviously collaboration. As a team, you work against one source of truth. You can work in isolation on a so-called branch, and I will explain that concept a bit later, and then integrate the work together. Git allows you to maintain a consistent track record of who changed what, when, and why. So Git version control comes with its own metadata. So whenever you submit work, some things will be tracked automatically. Basically, the what and the when and the who. And the why you can actually explain, and that's a very good practice when you work source-based to basically do your contributions in an explained way, and that's very much baked into Git and Git-based development. So that also allows you to revert to earlier states of your metadata and rollback changes, which is very hard when working org-based. You can execute control and QA on work submitted by contributors very easily, because all changes go through Git. They are available basically in raw form, visible in metadata, so you can do manual code reviews, which is a very common practice for code and works very well. It might hit its limit on some metadata like flows, which are very hard to read with a human eye as of their nested XML structure. But you can add automation, and there are great tools that allow you to implement all kind of quality checks to all the work that gets submitted. And very often people think of static code analysis, which helps you to make sure that you avoid, for example, security violations or potential anti-patterns in your Apex code. But actually the ability to execute such automated quality assurance or quality gateways goes far beyond code. So that's also applicable to no code, low code, other metadata. So for example, you could set up a quality gate that says whenever a custom field is added, we want it to have a help text and a description, and otherwise we decline that submission. That's a level of basically QA that you can hardly ever execute in a org-based development, unless of course by doing everything manually, but it really opens up the world of automation for quality checks, but also for much more. So you can automate your deployments, so you can automatically shift a certain set of metadata changes across environments, and we will briefly touch upon the topic of CICD later in this talk. And another advantage I've pointed out is reusing or even productizing your work. So that's an idea that might be, or a concept that might be less common in basically when you are a team working at a Salesforce customer on a single org, but it becomes very attractive when you are, for example, in a multi-org setup where you would not want to re-implement work time and again, but syncing in basically products, sets of metadata, and bundling those for deployment. Salesforce has a packaging mechanism for that is not only accessible for teams who release work on the App Exchange, but basically to every team. So all that basically is perfectly possible, or partly even based on the idea of working source-based. Okay, so now I'd like to just explain a few core concepts of working Git-based. So starting with basically what Git is, very obviously it's a version control system. It's the most common version control system. It's that or gained that popularity all across software development, all across the globe, that sometimes it's used synonymously with version control. So I just want to mention that there are other version control systems. There are such that have been around for longer than Git, SVN or Mercurial, but from my experience, you will hardly ever encounter them in a Salesforce context. So we can assume that working source-based is more or less synonymously with working Git-based. And now a few key concepts of Git version control that are important to understand for everyone participating in a Git-based development lifecycle. So I mentioned that a certain basically overhead of setting up the automation. I mean, that's a task that is typically accomplished by a release manager, a senior developer, an architect, a technical person, because it somehow is shaping your application lifecycle, will inevitably need some technical expertise, but actually contributing to a Git-based development lifecycle can be made very easy with tools. That said, I think it's fundamental to understand some key concepts. So I will just briefly talk you through the main ones. So a repository, a Git repository, that's in essence a storage space, a smart storage that tracks and manages your project's file history, provides you that audit trail, or this history of who changed what when. A branch, so that's a separate line of development. So you can think of a copy of your, in this case, project's metadata, because project metadata, Salesforce metadata, is what you, in the context of Git-based Salesforce development, would store in your repository. So yeah, think of it, you create a branch, you are on a copy, you can work there in isolation or collaborate with others without affecting the main project. A commit, so that is basically saving a snapshot of your work. So when you have performed some work that you want to persist, not necessarily deploy already, but persist, you would do that in a commit, which is timestamped, which is basically associated to your account, and where you ideally provide some brief explanation for your team on the thinking of behind your work that you performed. And then the pull request, that is basically telling your colleagues, your release manager, your peers, that you have finished a certain piece, and you request to merge, to integrate those changes, the changes from your branch into another branch, very often the main branch, which reflects the main development line, or very often the state of your production work. What I also want to mention just in my Git 101 is that Git is not equaling GitHub. That's quite a frequent misconception. So Git is open source. Git is technology that is agnostic of any vendors. GitHub is basically just very prominent, I would say the most prominent name in that landscape of Git hosts, Git providers, but there are others. So and it's great to know that your work is largely interchangeable. So your actual Git repository, no matter if it's hosted on GitHub or any of the other vendors like GitLab or Atlassian Bitbucket or Azure DevOps, can basically be moved between those only when it comes to adding automation, often referred to as pipelines, to your repository, specific files that instruct what happens, for example, when a commit is made or a pull request is opened. This basically will depend on your vendor, on the Git host you are using. That's just worth mentioning to avoid this frequent misconception and confusion. Now I'd like to briefly speak about branching strategies, because that's one of the key decisions to take when you decide to start working Git-based with Salesforce. When you set up a Git-based, source-based development lifecycle for your team, that's an important decision to take. And I will not go into too much details on the various branching strategies. We actually do a webinar in 2 weeks from now. We will later share the registration page for those interested in diving deeper into branching strategies, which will be basically an advanced Git webinar, very specifically focusing on this topic. But just very briefly, so here is a sample, a quite common branching strategy like called Git flow visualized. So basically, what you see here are the various development lines, if you want, so the different branches. And the branching strategy basically informs or instructs from where you start your work and where you integrate it to, and then how this basically relates to deployments, to making releases, because very often you will want to collect a couple of work items that you address, each of them represented very frequently in their own branch. So that would be a so-called feature branch, a short-living branch, a sideline of your development which you dedicate to an individual feature. So in this flow here, this is represented in green. So you basically have your main develop path, then you branch out to do individual features, you merge them again in, and then basically in this model, the main branch is used to mark certain releases, which would then either be manually or automatically deployed to higher environments, typically to production. There is a kind of, maybe controversy about different branching strategies by some people advocating environment-based branching, which is basically the attempt to reflect various environments, your production obviously, but also let's say your UAT or development sandboxes in long-living branches permanently, which obviously creates a certain overhead. And on the other side of the spectrum, there are very slim branching strategies like scale trunk-based, where the idea is you basically spin short-living feature branches of the main development path. You aim for keeping them very short-living. You integrate quickly, and you also follow a quicker release cycle and try to get your work deployed in smaller chunks. So obviously your choice of branching strategy depends very much on your project, on your team size, on the way you do QA. So there is no one-fits-all solution to basically inform your branching strategy. But yeah, there are several common, basically widely used branching strategies with their pros and cons. And yeah, as mentioned, we will elaborate on that in a separate webinar. Another concept which I'd like to just mention briefly is merge conflicts and their resolution. So quite often, and I think it goes back to basically coming from an org-based development where you know that if parallel development happens in two sandboxes and you touch upon the same resource during your work, which is a common scenario because the way Salesforce metadata is built, well, two people might work on different stories, might add a field to a page layout of a standard object, which however is shared. And so that obviously leads to the need to integrate that work, and in an org-based model, quite frequently to these overrides that I mentioned, or to the necessity to avoid those. In an org-based model, basically the tools have evolved which aim to compare the state of metadata in certain orgs. So let's say advanced org-based development without using a version control would basically, to avoid these overrides, have you check basically the metadata, state of metadata in the org you are deploying your work to, and then pointing out certain conflicts. In a Git-based model, that is quite differently, because before you even deploy to a target org, you integrate work in Git. And Git is actually great at integrating work. So not every situation, or I would even say that in the minority of situations where several people work in parallel and touch upon shared same resources, would actually lead to conflicts, because by design, Git is made to integrate work from different people, and it has all kind of smartness in there, basically taking into account when the work was started, to basically take automatic decisions on what is the correct state. Obviously, there are situations where merge conflicts can happen. So typically when you touch upon, speaking of Apex or triggers or LWC, when two people touch, let's say in parallel on the same line of code, and basically each of those changes might be valid, but then at the time of integrating those, of merging, there has to be a decision taken which of the lines is now the latest and the correct one. And that's where the manual work of handling conflicts comes in. So it is a skill that your release manager or the person basically overseeing the development lifecycle should be comfortable with. But yeah, I think it's very crucial to understand that merge conflicts are rather the outlier and not the standard when working in parallel on shared resources, touching upon the same metadata. So the last concept I'd like to elaborate upon in the context of Git-based development is CICD, standing for continuous integration, continuous development, sometimes mystified terms. So yeah, explained easily, what is CICD? So with the ability of a version control system to trigger on certain events, so assuming a person commits work or opens a pull request, or a pull request is basically merged, integrated, you can start automation. And in the earlier days, I would say that has typically been separated. So you had your Git provider, which basically served to host your Git repository, from which then every participating team member would basically have locally copies, so-called clones, and work against this one cloud-hosted repository where all the work gets integrated. And that was separated. So when a certain trigger happened, a pull request was opened, very often a separate tool was used as a CI/CD platform, which could trigger any kind of automation based on that. And the principle is basically always the same. So this CI/CD platform, it has the information on the trigger, so which is the very commit or the branch that basically had a modification, and then it can basically either perform some automation on the entire state of the repository represented in this branch, or on this very commit, or it can act on a diff, so it can calculate a delta to basically only look at the changes that someone has basically contributed with this very work item, this branch, this pull request. And then this automation, so typically these CI/CD platforms are very agnostic to what you do. So they provide a runtime environment where you can install all kind of tooling. So in a Salesforce context, very obviously you would, in your description of such a CI/CD, and those are typically so-called YML or YAML files, you would typically first install the Salesforce command line tool which would then open up endless possibilities, especially when enhancing it with extensions. So there are some very useful and widely used extensions like as Git Delta, which basically helps you detecting the very specific metadata that was modified on a specific pull request or branch. You might use commands coming from the native command line of Salesforce to, for example, spin up a scratch org and attempt a validation deployment there, or actually do a deployment to a temporary environment like a scratch org and execute tests there, or attempt a validation deployment to a higher environment, your UAT org, for example, or a dedicated integration sandbox, and give the person who basically submitted their work or the release manager detailed information on, is that work integratable? Do the tests still pass? So for example, that would be a common use case to run all Apex tests on that new integrated source. Leverage a free tool like Salesforce Code Analyzer, which is actually a collection of tools that empowers you to automate quality checks, quality gateways, as I've outlined earlier in this presentation. So in essence, open source is your friend here. A lot of useful tools has been contributed that help you basically gradually build out your automation triggered by events happening on Git. So the very common triggers you would want to base your automation on are basically a pull request gets opened and the pull request gets merged. So in the first case, you would run basically everything that informs the person being responsible for integrating and the person doing the changes if the work is valid and up to the quality standards and integratable. And the actual merge would often be used to then trigger a automated deployment. In my slides, I have linked here a sample repository on GitHub, which has a lot of open source solutions, or basically a collection of tools from the open source landscape that are widely used to help you building up your CICD. You can also what's probably important to understand, depending on the Git host you choose. I mentioned earlier that the Git hosts, the common ones, they nowadays all serve as CI/CD platforms, and they might have slightly different flavors in how you craft this configuration that gets triggered by a commit, a pull request open. You might search specifically. So if you decide for a Git host like GitHub, then an obvious choice would be to use their CI/CD capabilities, which are called GitHub Actions. So you would probably search for commonly used GitHub Actions that apply certain automation for Salesforce teams. If you are, let's say, in the Atlassian ecosystem, because your IT department might have decided to host their Git repositories, let's say also from other contexts than Salesforce on Bitbucket, then you might use their CI/CD platform, GitHub Actions. However, as mentioned earlier, you can also offload CI/CD into a third-party platform. In any case, the syntax, basically how you define these automated actions, these pipelines might differ between the platforms, but the actual executable codes, like installing the Salesforce command line or leveraging extensions to that, that will be, again, portable between whatever CI/CD platform you use. Well, so to round up, I'd like to provide some guidance or steps in how to get started. So first of all, I would suggest to take a deep dive on the basics of Git. I've linked the trailhead here. I mean, obviously, Git being such a widely used technology, there is no limitation in availability of resources that help you basically understanding or increasing your understanding of the core concepts of Git. But I think looking at Trailhead is, as for starters, is never a bad choice. And then actually transforming or getting started with Git-based development involves a lot of steps. If you are basically owning your development lifecycle, or if you are pioneering on your own, basically Git-based development, there are a set of steps that you have to go through, and those include installing some necessary tooling, like you will need Git on your machine, the open source technology Git. You will need an integrated development environment, typically VS Code. You will want to probably once fetch your metadata from the org you are developing against, so your production org, or in case you're at an ISV, probably your packaging org, your developer edition, and want to put those changes under version control. So that are basically the initial setup steps. And then for following a Git-based development, I highly recommend looking into tools that make this accessible also for less technical team members. So for developers, it might come quite natural to use the command line to basically execute tasks like fetching metadata from a development environment, fetching specific metadata that is in a so-called dirty state, which has been touched, and then basically committing this. But there are great tools, also free tools with Salesforce DevOps Center might be a good starting point to basically enhance and make your Git-based development lifecycle accessible to all team members, to basically low-code contributors and developers alike. And another fundamental task before rolling out or switching to Git-based development is obviously to define your org strategy. So you will very typically set up, I mentioned it in on the first slide. So development is strongly recommended to happen in developer sandboxes or scratch orgs. We could have a separate webinar probably on the pros and cons of scratch orgs versus developer sandboxes, but that would lead too far. And then you would also have to decide where you want to do the QA, where you want to actually integrate changes and how you basically move them to production. I mean, that again depends on the size of your project, the size of your team, the complexity involved. If you work with basically several stages, or if you have a very simple setup where you would eventually go from the development environments to Git and from Git to production, or through one integration org where your manual QA and acceptance testing happens. So again, different org strategies, different branching strategies, as mentioned. And recommended is to look into tooling and to move in small steps. And once you have unlocked the power of Git-based development, once you have empowered your team members to naturally and easily move changes from their development environments to Git, you can basically unlock the unlimited potential of adding CICD to gradually, that's my suggestion, add automation, be it quality checks and or be it automating your entire release process for increase of efficiency and quality of your releases. That said, I'd like to open the floor for questions.
Amazing. Thank you so much, Harold, for such an informative presentation. If you have any questions, do pop them in the comments and we'll get around to as many as possible in the next 15 minutes. We do have a few questions that came in. So the first one is, how do I set up a Git repository for a Salesforce project?
So basically you can bootstrap. So what you will need is, as a kind of a container for your Salesforce metadata, you will have to create a project, an SFDX project. And these steps are perfectly covered. I have linked, I think, from my slides, and we can share it later, an article I had contributed to Salesforce Ben a while ago with one of my team members on taking you exactly through those steps. But yeah, in essence, you can either use a command from the Salesforce command line interface to bootstrap a project that will just create a naked structure of folders and so on, where you can then basically fetch your metadata into with another command of the Salesforce command line. Or you can get started. There are templates available on the popular Git hosts where you can basically find a great starting point of a boilerplate Salesforce project structure with all the necessary configuration files and folders, and potentially some additional useful tools. So such a template might already include a simple pipeline to automate some aspects of your deployment or integration work. And they might come with other useful tools like basically linters, which already enforce certain harmonization on code on the actual client's computer. But yeah, basically these are the two options. You can basically start your blank Git repository and then a empty Salesforce project with command line tools, and yeah, then bring in the metadata and then start from there with your Git-based development.
Amazing. Thank you. Another question here. Have you already met clients who regretted to switch to Git-based CICD and went back to change sets?
I can wholeheartedly say I didn't. So I think, yeah, I would dare to state that no one ever regretted that step, because yes, as pointed out, there is an initial ramp up, there is a certain learning curve. But once you are used to the transparency and the ability to add automation and to execute a certain level of control and visibility to your metadata, I think you would never want to go back to this black box approach of working in an org and then shifting metadata to another org. Yeah, I can I can answer that. I have, I think, never met anyone regretting it, but I can also say that it might come with some pains. The actual transition phase, you will have some learnings. I mean, there are specific metadata that you might want to find not suitable for putting under version control, and again, that highly depends on your style of work, but you might want to leave the flexibility to your team, because I mean, let's figure it. Salesforce is a no-code platform, and it's excellent in that. And of course, playing everything through a proper development lifecycle and through version control creates some overhead, and you don't want to frustrate your users by taking away the ability to do certain changes the easy way. And so it might be, for example, for your personal reports or dashboards or yeah, maybe even list views. You might let the freedom to your team to do changes directly in production and not play them always through, let's say, a proper life cycle through Git and the deployment. But yeah, in essence, working Git-based is also officially recommended by Salesforce and is a good practice you should aim for and that you will not regret.
Perfect, thank you. Another question here. So Git Sourcebased only works with Scratch orgs. How do extensions fit in, like CPQ, etc.?
Very good question. So I would argue that source-based development works not only with Scratch orgs, but also with developer sandboxes. You don't get the same level of control. So what is excellent, just very briefly on Scratch orgs. So they come up completely blank and you basically shape them to match whatever target you're developing for. That can be your production org or your package if you develop for AppExchange. And so one could argue that true source-based development is depending on Scratch orgs, because in sandboxes, since they are not initially populated from your repository, but cloned or refreshed from another org, they might be created as a replica of production, they might be created as a replica, a clone of another sandbox. So if you're very strict, you could argue that's not pure source-based development, but many teams show that they work source-based in development sandboxes. Again, tooling is very powerful here. I only want to mention a sandbox pooling can be quite a game changer to keep your sandboxes very short-living and hence kind of in sync with Git. But yes, so working with sandboxes adds a certain complexity, but absolutely not unsolvable. That on the first part, and then to CPQ and other extensions, AppExchange packages. So first of all, when you work in sandboxes, they will typically refresh, including those. So they will replicate your production environment. In Scratch orgs, you have to take care of that. Again, tooling helps. So there are teams working Scratch org based who have very complex configuration steps, like installing several managed packages their project depends on. You can do all that. You can automate it for Scratch orgs. For sandbox, that comes. What is very specific, and I guess the question aims on that, with CPQ and some other extensions, be it basically AppExchange packages, for example, for PDF generation, there are some popular tools, or Salesforce native CPQ or external CPQ. So what they, or field service lightning, what they have in common is that they have record-based configuration. So there might be something that you might consider part of your configuration, which however technically is stored in data. And that brings some complexity because Salesforce metadata and data work slightly different. So most things that I have covered here were per se only applicable to metadata. So if you now have crucial configuration records, they would per se not be part of that life cycle of basically tracking changes and moving them from org to org. But of course, you can also manage data deployments with automation. So you can include, it requires a bit more ramp up effort, but you can make sure that your team members can basically modify configuration records and also persist them into Git. They might be stored similar to metadata, but it's not taken care for you out of the box. Let's say you will have to find your own way. You might use powerful extensions, SFDMU. I want to mention it here. It's a great command line tool for data deployments, which you can use to shift your configuration records or play them through a similar Git-based development lifecycle where they go to code review, where they will be part of your branch, and then they will be integrated together with your pull request merge and might trigger an automatic deployment of those configuration records.
Great, thank you. Another question here. Can you do source-based development without having to create a managed package? So this person's only used source development in the context as an ISV, but they want to know how to differentiate between developing for a singular org and developing a managed package.
Yes, so absolutely. It is possible. It is very common. It's widespread, and it's even recommended by Salesforce to also work source-based in the context of developing your single Salesforce production org. In essence, from a working with Git perspective, it's not that different. So if you work at an ISV, you might have your, ISV is where I would say pioneers in working with scratch orgs, and they are somehow used to thinking and working source-based probably for longer than the concept source-based had hit the mainstream in Salesforce development. Also worth mentioning, in the ISV landscape, Salesforce even made it the default. So there had been a time of so-called first generation managed package, which was quite org-based. You had your one developer edition org, your packaging org. It was the source of truth. You got your metadata in, and then you built a package from there. But with the advent of second generation package, basically they switched the model to be completely source-based. So you will not even have to actively deploy your source somewhere for producing a package. You basically do your development in scratch orgs, you commit your changes to Git, and then you decide from this branch, from this moment in time in Git, I want to build this package version. So it's true, it comes somehow, might seem a bit more native or connected to package development, the whole idea of source-based development, but it's absolutely not exclusive. So it's also not exclusive to scratch orgs. So you might use sandboxes, and you might develop sandboxes, and you can still perfectly track your changes, integrate them on Git, and from there basically deploy them further up to your production org.
Excellent, thank you. Another question here. What purpose do you have for using GitHub CI/CD if you have a strong Apex testing framework? Do you put front-end testing there, for example?
Yeah, very good question. So that's one use case I haven't even mentioned, basically doing automated front-end tests. So basically spinning up a non-visible browser and having an automation click through the UI. That's something you can do on CI/CD, but also executing your unit tests. So for example, in an basically more sandbox world, you might want to set up a CI/CD which does a validation deployment, and when you open a pull request basically executes tests in that context. Of course, that might create a bottleneck. So if you all deploy against a single org, you have a larger team. That is when things become difficult, because then the deployments might take long and they might queue up. So that is where scratch org-based development shines, because with scratch orgs, you can actually spin up from your CI/CD an entire fresh org. You deploy the very metadata of this work that you aim to integrate, the state of your source at this very moment, and you can execute your unit tests. So it would actually give you, it kind of shifts left your QA. Already when you open the pull request, you will get the information, basically the combined source, my work with the current state of work, will that have all unit tests pass or will they fail? So in a very refined development lifecycle, you would really aim to execute as many unit tests as possible on every pull request that gets open on the combined source of that very pull request with the main source against which you aim to integrate that work.
Amazing, thank you. And that takes us to the hour now. So I'll be wrapping up the session. Thank you, Harold, for answering everyone's questions and also for taking us through the whole session as well over the past hour. And thank you, everyone in the audience as well, for your participation and also for your questions as well. Do feel free to connect with Harold on LinkedIn, follow Hutte as well. And I'll very quickly share the link now to the webinar if you would like to sign up and find out more about Git. I'll pop the links in now. Amazing. But yeah, that is everything from me. Thank you again for tuning in, and I hope you have a wonderful rest of the day.
Thank you very much.